So in the last video, we saw how to draw line charts using Matplotlib. But imagine if your data is not something of a trend or something that evolves with time. Let us say you have the scores of your students given the amount of minutes they study. So let's go ahead and try to plot a line chart for this data. So as we can see, we cannot really get a lot of information from the line chart, and it's really hard to understand what is going on. So for a data like this, line charts are not particularly helpful. When your data is in the form of a relation between two variables, it's much more effective to see it in the form of a scatter plot. So even making a scatter plot in Matplotlib is very easy. We just use the scatter method, plt.sca scatter core 1 minutes. So now if we see, so as we can see, it is much more easier to see the relation between the two variables in a scatter plot. As we can see over here, there is a clear positive correlation between the two variables. The students who studied more got a better score. So let us say we also want to plot the scores from another subject. So as we know from the last video, we can just plot it again and it will be plotted on the same graph. And let's give them both a different color and a different marker. So it looks okay, but as you can see, there are some data points that are overlapping and it is really hard to distinguish and it is really hard to see them, as you can see over here and over here. So what if we want to plot both of them but not on the same graph? So in Matplotlib, you do that using subplots. So for that, instead of plotting this using PLT and using the scatter method on PLT 2 times, what we do is use the subplots method from the PLT. So we say figure AX equals to subplot, and you can give the number of rows and columns. So n rows 1 and number of columns, let's give 2. And then instead of scattering on the PLT, the AX gives us an array of the subplots that we create. So this subplots method returns two items, the figure and an array that consists of all the subplots. So in the first subplot, we plot this, and in the second subplot, we'll plot the score from different subject. So now if we see, so now over here, as we can see, there are two different subplots and much easier to compare them. But as you can see, something feels off. They both look very similar. But if we look at the data, we can see over here that there is much more variation in the score 1 than there is in the score 2. So what's wrong over here? So if we just by default let Matplotlib take care of the accesses, it makes the accesses such that we can see the individual plot very easily. So over here we can see the access ranges from 60 to somewhere around 75, but in the blue one it only ranges from 64 to 68, but it makes them look very similar. So to avoid this, we can use a method on the plots which is called the access method on the plots, and pass it the equals argument. And let's do the same thing for the second plot as well. So now if we run this, so now as we can see, the the x-axis of both the plots have been made equal. So in this, it still looks very similar, but it is much more obvious that there is a little more variation in the test 1 scores and a little less in the test 2 scores. And making the axis equal is not just good for comparing two different plots. Let's say you have the scores from test 1 and test 2 and you want to compare them. Just running this normally, we can see that a plot is made with a lot of variation in both the x-axis and in the y-axis. But over here, as we see, the x-axis is not even comparable to the y-axis, and the plot is very misleading. So if we use the same technique over here, then it becomes much more apparent that there is much more variation test in the grades for test 2 than there is in the grades for test 1. So taking care of the axes when making scatter plots or actually any kind of plots is also very important. Otherwise, your plots can really be misleading. Okay, so one more thing. What if we also want to annotate these points on our graph? How can we do that? So let us see. Let us say we also want to add labels for all these students. LABELS labels. So we make another array. So let's call the different students A, B, C, D. And to annotate each of the labels, we actually have to annotate them individually. But we can do that all together is using a for loop. So for ld.anotate annotate, we just pass it the label, and we also have to give it the xy coordinates. Also, let's make the label a little offset from the point, so the point is much more clearer. So the text of the xy would be offset by 5 and -5, and we have to make text chords equals to offset points. So that way we are telling it that the text should be rendered uh, 5 pixels ahead in the x direction and 5 pixels behind in the y direction from, and these are the offset values, so 5 -5 from these actual coordinates. So now if we see the chart, so now as we can see, the coordinates also have labels. So now this is A, this is D, so it is much easier to distinguish individual students in the plot. So this is how you make scatter plots in Matplotlib.